Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, my friends, to my YouTube channel Drilling and Workover. This is Abdelaziz Gabr. I am accredited instructor in IWCF Well Control and IEDC Well Sharp. Also, I am accredited instructor in IEDC Mod Engineering for Basic and Advanced Mod School. Today, inshallah, we will continue in the third lesson of the Advanced Mod School. It's very important because it's about very vital and very important topic. It's called solid control equipment. Actually, the solid control equipment is very important for the mod engineer, for the rig crew, and for the drilling supervisor. Why? Because as I told you, this is the first or this is the most important defense or defensive line against the solids. With the solid control, we can minimize the solid amount in the mud to the minimum required or to the minimum. Okay, so we have to take care of the solids control, and also we have to know some characteristics about them. Okay, we will talk about each one of them in detail, and inshallah, it may take from 2 to 3 or maybe 4 also lessons. So please pay attention to every word I will say today, inshallah. What are the content or the agenda of the solid control equipment? Number one, the solid control philosophy. How can I control the solids? Okay, what are the methods that I can use to make the solids to be minimized or to be minimum? Okay. Uh, Number two, the economics. The economics means how about the cost that you will pay to make the good parameters for mud, especially for the solids. So how much you will pay as a cost for the mud treatment. Number three, what are the types of the solids? Okay, the types of the solids. Number four, the shale shaker development and its technology. And the forces, maybe elliptical, maybe circular, maybe linear. What is the difference between each one of them? And which type of the shakers is compatible with each one of them? So this is very important topic also. We will talk about the hydrocyclones, which is the desander with the desalter and the mud ejector or the mud cleaner. So there are the three types of the hydrocyclones. We will talk about the centrifuge and if it is bright recovery or it is just to take all the low gravity solids. And also for the centrifuge used in the dewatering. And what about the mud treatment like the auger or something like this? So we will take care about all these. We will talk about all these equipment, the cutting dryers, for example, and we will talk finally about the mud mixing, the agitators, and the mud guns, the hopper, all the mixing equipment for the mud. We will take some notes about it and about the mud system. And finally, we will talk about the evaluation of each of them. Okay, so we will talk about the screen development technology to make evaluation for the shakers, and we will talk about the evaluation of each one of them to know if they are working properly or not working properly. These are the solid control equipment as you see here with the optimum cut points. We will talk about what's the meaning of cut points. Okay, so as you see here, this is a scalping shakers which you can separate up to 600 microns and above. This is a linear shakers, okay, and we will talk about the difference between them. This is the motors here in the horizontal or on the side. Here from the above, here are the vibrator or the motion from the motors here. This is a linear shaker. It's 74 micron. The desander up to 44 micron. the desalter up to 25 micron, and the mud cleaner also. And finally, the centrifuge, it can make separation up to from 2 to 3 micron or the colloidal particles. So take care of all these. We will talk about each one of them in details. Okay. Number one, the API classification for the solids. The classification of solids and in microscience. Number one, the colloidal which is less than 2 micron, it can be separated by the centrifuge. The ultrafine from 2 up to 44, this is can be separated by the desalter. Fine, which is from 44 to 74, can be by the descender, and the medium it can be separated by the shaker, okay, or high API shaker, for example, from 74 up to 250, and the intermediate one from 250 to 2000, which is also taken by the shaker, which are mainly, it can be like the cuttings, okay, and this is also the same category but in different words, okay, and the chemicals that can be separated here, the colloidal, for example, like bentonite, like clay, like ultrafine drill solids, the silt like barite, volume like silt, like fine drill solids, the sand the sand, this is the sand and real solids, the gravel more than 2000. Take care here from the cell to size and take care of this number. It's 74 micron. So all the mesh screens, or this is lower than 200 mesh, which is API plus or minus 170. No problem about this information now, but this is the size of the barite. So all the screens cannot separate the barite. Screens cannot separate the barite. So take care of this important note. This is the same classification, but in other words, as you see here, this is the gravel, okay, and here the screen mesh, the mesh screen, as you see, from 10, uh, 20, 30, up to this is API, and this is the mesh screen. So we will talk about all of them later, inshallah. Here, this is a comparison, okay, to know why we make this comparison. Here's the recommended range of solids in water-based mud. This is the recommended range, for example, the minimum solids in the water and barite only, and here the maximum solids of the water and clay only. So take care that this is the recommended area or the recommended range that the solids or the low gravity solids must be inside it, or the total solid volume must be inside it. For example, for the 12 volume, for the volume of the 12 ppg, the solids water-based mud, for example, it can be plus or minus 20 or 17 or something like this. Okay, it can be in this range. Okay, so the 14 it is more than that, and the 16 it's more than that, and finally the 18 is more and more. So take care that why we are talking about this, because if you need to make hami solid analysis, but you don't have the simulator or the computer, or you don't have the calculations that is required. So this is the graph that gives you fast figure, or it can give you quick informations about if the mud is in the good range or in the proper range of solids, or the solids are higher or lower. So take care of all of this. Someone may talk to me, can the solids be lower than the required? Yes, if you are making dilution, if you are adding salt to the mud, so that the salt will make raise to the will rise the or will increase the mud weight, and so that the solids will be very little. So take care of all these points because they are controlling the solids. Now, what are the methods for solids control? or the ways to obtain a desired fluid properties. Okay. Uh, Number one is the dilution of a new base. Okay, the dilution of a new base dilution by addition of a new base fluid. Uh, and we have talked about this. Number two is the displacement, which is a partial replacement of the fluid. Number three, which is the main topic of our lesson today, which is the mechanical separation or the removal of drilled solids by particle size and density difference in the, for example, in the solid control equipment. And the number four is the settling, which is used mainly in the settling tank. Now, as I told you, we will talk about the philosophy of the separation or the philosophy of solid control. As here, there is something called Stoke's law. His name is Stoke, and he made a law in order to control the solids separation. For example, here the settling velocity, okay, equal to multiplied by the gravitational or the acceleration of the gravity multiplied by the dc, which is the density of the cutting, and multiply by bs, which is the mud weight of the solid minus the mud weight of the mud, and here multiply by constant multiplied by mu, which is the viscosity. From this, we can notice that as the viscosity is high, the settling will become very low. Is the same situation as in the well. Okay, as in the well. If the gel strength is high, if the gel strength is high or the viscosity is high in the well, the settling or the V settling or the velocity of the settling velocity will be very low. Like the slip velocity, for example, will become very low. The same in the tank or in the settling tank. If the viscosity of the mud is high, this means that the mechanical or the attraction between the solid and the mud will be high, so the settling velocity will be low. So take care of this very important note. Number two, here the g as the acceleration of the gravity. Number d here is the particle diameter. Number bs here is the density of cutting or of the solid. So number bm okay means the density of the mud, and mu means the viscosity of the mud. So from the Stokes law we can get some information. Number one, the larger particles of the same density settle more rapidly than smaller ones. This is why, because this is the D. D here is the particle diameter. So if the particle diameter is very large or is larger than the other, it will settle rapidly more than the other or before the other. So this is number one. The larger particles of the same density settle more rapidly than smaller ones. Number two, the high density solids settle more quickly than the low density one. Number three, the high acceleration and low viscosity speed up the settling rate. So the first method of making a solid control, it's called a settling tank, and in some words they are called the sand trap. The settling tank is the first tank or the first bit under the shaker. Just once the mud are coming from the shaker, they are going directly to the settling tank or to the sand trap. It's the same meaning. Okay. The settling bits simply use the force of gravity to separate solids. So all the solids are separated under its density or the force of the gravity. Number two, the larger and the heavier solid. Okay, the larger or heavier a solid is, the faster it will settle through fluid in the settling bed. Number three, the sand trap is a compartment without agitation. Why without agitation? Because agitation can make remixing for the solids again and become suspended in the fluid. So we need it to become static. So we don't make any agitation, or there is no agitator in the sand trap. Number four, the sand trap removes the larger solids that might block cyclones or hydrocyclones or other equipment downstream. And finally, very important point in the settling tank. Take care of it. The sand trap should have a slanted bottom. Slanted mean inclined, okay? A slanted bottom and a quick opening, quick closing dump valve or gate so that the settled solids can be discharged with minimum mud losses. With minimum mud losses, and it's preferred to make these dump and dilution through the connection. As you see here, this is the tank. Here the shaker, for example, and the solids are coming on, or the mud is coming from here. So this is a slanted bottom, which means it is inclined bottom. Okay. So the inclined bottom reach to the dump valve so that the solids with larger particles, okay, are settled and all are accumulated in the bottom here, okay, as you see here. And then once you see the solids are too much after making the retort test, Hami, you can go ahead and open the dump valve and make dump to this solids and make dilution with fresh mud or dilution with base fluid. And at this time, we are making a dump and dilution in order to keep the solids to become as low as possible. So this is very important equipment in dealing with the solid control. The settling also, the rate of solids settling in the settling tank or the sand depends on the size and shape and the specific gravity. Number two, the density of the drilling fluid. Number three, the viscosity of the drilling fluid. And as I told you, if the viscosity is high, we can make it low. But take care here how we are making the viscosity to become lower than the required without too much change in the mud parameters. Actually, we make the dilution inside the sand trap. Okay, we are opening a hose of water, for example, or diesel base fluid in the sand trap. So that in the sand trap, for example, if you are making dilution 5 barrels per hour or 10 barrels per hour, and you have to open it in the sand trap. Why? To help to reduce the viscosity so that the solids are the solids can be settled to the bottom quickly. Okay. Here also the type of the fluid flow regime. Also the residence time in the bit, or it's called and sometimes the retention time, which means how long the solids will stay in the tank so that it can settle in the mud bit. Number two, and this is the most important one, it's called the shale shaker. And take care of the shell shaker because we will talk about it in details. But today we will talk in humi about it. As you see here, the mud are coming from the flow line to the something is called bosom belly. Okay, this is the bosom belly, and then the discharge is coming from here. These are the screens. Okay, and this is the cutting to become discharged here in the disposal bit, and the mud return to the bits are coming from under the screens and coming from this place. And as you see here, this is the vibrator or vibrating assembly or the motors which help to make vibration and make shaking to the shakers, and so that you can get rid of the cutting without making any problem for the mud. Okay. The first type of the shakers, okay, it cannot be considered a shaker, but its mechanism is like the shakers in the old version because it has a scalping shape or a scalping shape. It's called jumbo box. It's called the jumbo box. Jumbo box will remove the sticky clays or jumbo clays or jumbo shale by utilizing a moving screen or a moving chain. Sorry. By utilizing a moving screen or moving chain rather than a vibrating screen shakers. This moving screen or chain filters the mud and separates the sticky clays or jumbo from the mud. Then the jumbo box is primary in the offshore rigs, mainly in the Gulf of Mexico, where the jumbo shale is the most common. As you see, this is the jumbo box, and here, as you see here, this is a movable or moving chain, and this is the gear. Okay, as you see here, this is a gear, and this is the moving parts from here, or here the motor or whatever here is the motor which gives the shaker the moving action. So this is the gear as you see here, and this is the movable screen or movable chain, and this can take the sticky clay from here. Now we will talk about some very important definition or some very important abbreviations that will be used in the equipment inshallah later. Something is called the particle size and the cut point of the equipment. What is the meaning of cut point? What is the meaning of cut point? When I say that the shaker screen, for example, ABI 170 has a cut point, okay, D50 for example, equal, I don't know, but equal maybe 74 for example. What's the meaning of cut point? Actually, the cut point designations should include the percentage of the stated size removed. For example, if I say that the cut point should always be denoted with the letter D with subscript indicating the percentage removed. So if I say that the D50 or D60 or D80, okay, D80 of the screen ABI 170 equal, for example, 44 micron. What is this meaning? Okay, take care that when you are drilling, you have a mixture of sizes that this mixture of sizes can be from fine to ultra fine to coarse. Okay, it's because all of these are cuttings. But when I say that API is 170 for example, or a type of screen has D50 or D80 for example, D80 equal 44, this means that all the sizes above 44, for example 50, 60, 70, all above 44 will be totally removed. Okay, but the size 44, 80% of it will be separated and 20 will pass. Okay, and 20 will pass. So take care of this point, because D50 for example means that 50% will be removed and 50% will be passed to the mud again or to the mud bit again. When I say D80, A4, D16, whatever, so the subscript The subscript below the D number is the removable percent or of the percentage removed. Okay. Without this percentage, no two cut point sizes can be compared. A D50 cut point, for example, of 40 microns means that the 50% of the 40 micron size particles have been removed and 50 have been retained in the mud system. Here, this is a graph. Okay, this is a graph. What is the meaning of this graph? Okay, each solid control equipment has this graph. Each size of the screen in the shaker has this graph. For example, this graph is for the API 70. API 70, for example, it means, okay, I will talk about the screens in detail, but let's talk about it humi now. API 70, okay, is a type of screen. This is the D cut point or the D50. This is the D cut point graph for it. Okay. What is the meaning of this? This is the particle size in microns. Okay. This is the particle size in microns versus the percent particles removed by the screen. So that when I say that the D50, okay, D50 of the API 170 of the API 70 equal, for example, 35 micron. This means here, as you see from here, is the 30 here from, for example, 35 micron. Okay, this means that the all, okay, for example, all above 35 will be separated, but the 35 is half separated. Okay. For example, if I say that the D90 here, okay, this is 90%, and here this is the D90 of this screen is 58 micron. This means that the API 70 can separate 90% of the size 58 and 10% of it can become in the mud. Okay, when I say that the D100% or D100 of the solid for more than 212 micron are removed. Okay, so this is very important to know what is the meaning of D cut point or D50 or whatever the percent in it. Today I hope it was easy lesson, and inshallah we will talk in details about each equipment inshallah. Thank you very much for this lesson today, and inshallah I hope to see you later inshallah in other lessons. Please, if this video appeals to you, share, like, subscribe. This is your channel, not mine, and see you later inshallah. Thank you very much and goodbye.